All right, let's talk about data trees. Imagine this huge branching structure just filled with information. To make any sense of it, you need a map, right? A clear path from the very top all the way down to the bottom. Well, in this explainer, we're going to draw that map together. So here's the big question. You've got this tree and it holds tons of information, but how do you actually visit every single piece of it in a logical way? Think of it like this. You're exploring a giant mansion. How would you make sure you see every single room? Your path would totally change depending on what you're trying to do, right? Are you mapping the layout? Are you cleaning it? Or are you just looking at the art? That is exactly the problem we're tackling with data trees today. So how do we navigate this thing? Well, we're going to meet 3 expert tour guides. Each one knows a unique path through the tree. And what's really cool, what's fascinating, is that the massive difference between them all comes down to one tiny, simple change. And here it is, the secret sauce. It's all about when you visit the root. The main entry point of the whole tree. Our first guide, Preorder, says, let's check out the root first. Inorder says, nope, we'll visit the root in the middle. And postorder, it saves the root for the very end. That's it. I'm not kidding. That one simple change in timing is what gives each of these methods its own unique superpower.
Okay, tour number 1. Let's meet our first guide, the pre-order path. I like to call this one the copy machine tour, and you're about to see exactly why that name is so perfect.
The rule here is super simple, super direct. Root, left, right. You visit the root node first. Deal with it. Then you explore its entire left side, applying that same root, left, right rule all the way down. Once that whole branch is totally finished, you pop back up and do the exact same thing for the entire right side. It's always root, then all of the left, then all of the right. So you might be asking, why is this root first thing so useful? Well, think about it. Because you're dealing with the parent before you deal with any of its children, Preorder is absolutely perfect for creating a perfect copy of a tree. It's like you're laying down a blueprint, right? You put down the main foundation, the root, first, then you build out the left wing, and then you build the right wing. This root-first approach is also how we get something called prefix notation, where an operator, like a plus sign, comes before the numbers it's supposed to add. All right, on to our second guide. Welcome to the in-order path, which I call the library tour. And if pre-order was all about getting the structure right, you'll see that in-order is all about, well, order. Now, the pattern here shifts just a little bit, but it makes a huge difference. In-order traversal follows a left, root, right pattern. See the change? You first explore the entire left subtree. You process everything down that path. Then, and only then, do you visit the root node. And finally, you head over and explore the entire right subtree. So it's left, then root, then right. And this, right here, is why we call it the library tour. You see, in a special kind of organized tree, a binary search tree, where everything to the left of a node is smaller and everything to the right is bigger, an in-order traversal is pure magic. It will visit every single node in perfect, sorted, ascending order. It's literally like walking through a library from A to Z. This makes it the absolute go-to method anytime you need sorted data. And that brings us to our final guide, the post-order path. This one has my favorite nickname. I call it the Demolition Crew Tour. It sounds a little dramatic, I know, but you'll see it's incredibly useful for, let's say, cleanup operations. Okay, so the policy here flips things around completely. Post-order follows a left-right root policy. You explore the entire left subtree. Then you explore the entire right subtree, and only after visiting every single child and grandchild and everything else do you finally visit the root node. The root is always, always last. So why on earth would you save the root for last? Well, think about it like this. You can't demolish a building by knocking out the ground floor first, right? The whole thing would collapse. You have to work from the leaves up. Post-order deals with all the children first before it finally gets to the parent. This makes it the standard, safest way to delete an entire tree without leaving any messy, orphaned nodes behind. Okay, so we've met our 3 expert guides. Now let's put them all side by side and figure out how you choose the right tour for whatever job you've got to do. And honestly, it all comes back to that one super simple idea we started with. The only difference is the position of the root. Pre-order, root is first. In order, root is in the middle. Post-order, root is last. That's it. That single distinction is what dictates absolutely everything else. This table right here just lays it all out beautifully. Look at that visit order row. That's the core difference we've been hammering home. Now watch how that directly connects to the application row. You need to copy a tree. Preorders root left right is your best friend. You need sorted data from a binary search tree. Inorders left root right is the only way you're going to get it. You need to safely delete a bunch of nodes. Postorders left right root is the tool for the job. You see, the purpose flows directly from the path you choose. So, here's the crucial point, the main takeaway from all of this. There is no single best traversal. It just doesn't exist. There's no one-size-fits-all answer. The best path is simply the one that perfectly fits the job you need to get done. Are you building something, sorting something, or tearing something down? Your answer to that question tells you exactly which tour guide to call.
And that kind of leaves us with a final thought to chew on. We just saw how changing one tiny, simple rule, just when to visit the route, creates 3 completely different and incredibly powerful tools. It really makes you wonder, doesn't it? What other simple, elegant rules like this are quietly running our entire digital world, just sitting there, waiting for us to discover them?